Welcome to today's presentation. I want to believe that you are well wherever you are. Well, in today's presentation, we are going to look at matrices, and under matrices, the problem we are going to look at today is on singular matrix. So the question reads, given that matrix A is 2, 3, 4, 4 and matrix B is x, 1, 2, 3, and that AB is a singular matrix, find the value of x. Now in this problem, I want us to separate this from vectors. Now, many a times students fail to separate AB from the vector AB. AB simply means you're multiplying matrix A by matrix B. Unlike for a vector, we'll have vector AB, which is just the position vector of B minus position vector of A. So those are completely different things. So having cleared that, I just want us to go straight to the solution. And the solution to this we'll have as follows. Remember, we are told AB is a singular matrix. So first we'll have to multiply matrix A by matrix B in that order. So we begin with matrix A, which is 2, 3, 4, 4, and matrix B is x, 1, 2, 3. So in our multiplication, we multiply row by column, row of the first matrix by column of the second matrix. A student once memorized that by simply having row by column memorized as Roman Catholic. That was interesting, but whichever way you can go about it, just to ensure you remember, keep to it. Well, so we multiply this row by this column. So the corresponding elements here, you multiply 2 by x and 3 by 2, and then you add. So in our first row, we'll have 2 by x, that is 2x, plus 3 by 2, that is 6. And then we multiply again this row by the second column. So we have 2 by 1, that is 2, and then 3 by 3, that is 9. So 2 plus 9, that gives us 11. Next, for the second row, we'll determine as follows. We have 4 by x plus 4 by 2, that is 4x plus 8. And then for the second, the next element will have 4 plus 12, that is 4 times 4, 1, 4 times 3, 12. When you add, we get 16. So with this, we have the matrix AB. Now, if this is the matrix AB, and we're told it's a singular matrix, first we need to know that a singular matrix is just a matrix whose determinant is 0. So if you're told a singular matrix, then what you need to recall is that its determinant is 0. In other words, it does not have an inverse. So in this particular case, we have this as AB. So AB is a singular matrix. So we simply get the determinant of this particular matrix here and equate it to 0. And from that equation, we'll be able to get the value of x. So what I mean is this: get the determinant of this matrix, multiply the elements of the leading diagonal, that is 2x plus 6 times 16. 2x plus 6 times 16, and then you subtract the product of the elements of the second diagonal, that is 4x plus 8 times 11. So we have 11 into 4x plus 8. Remember, this should give us the determinant. So At this particular point, we have here as this is 32x plus, I believe this is 96 minus 44x minus 88. And then because it's a singular matrix, the determinant will be 0. So we equate this to 0. So here we'll have 32 minus 44, that is collecting the like terms. We'll have that as, this is negative 12x. And then 96 minus 88, so that should give us plus 8. And then we equate that to 0. So taking 8 to the other side and dividing both sides by negative 12, so we'll have, or rather, let me take it slow. We'll have negative 12x is equal to negative 8, and then dividing both sides by negative 12. So we'll have x is equal to 8 over 12, and 8 over 12 simplifies to 2 over 3. And thus we have the value of x as had been required. Find the value of x. So finally, we have come to the end of this question. Thank you for staying with me. Thank you for watching. I hope to see you in the next video.